Alright, welcome to another video. This video we're going to look at the chain rule. And it's pretty easy. It's not that bad. So let's go ahead and get started. So here we have the chain rule. We've got the derivative of u raised to the n with respect to x is n times u to the n minus 1. So we take the exponent, we bring it down in front and subtract 1 from the exponent. But then it's times the derivative of u. All right, so let's look at it this way. Okay, so if you have, see, this is like your u right here, something in parentheses raised to a power. So the chain rule says you got n times whatever this is in parentheses to the n minus 1. So you bring the n down, subtract 1 from the exponent. But then this stuff here inside the parentheses, whatever it is, you have to take the derivative of that. And that's all it is. Okay? So let's get started on some examples. We've got quite a few examples to work, and we got some word problems to do. We'll do the word problems at the end. So it says find the derivative. So we get y equals 2 minus 3x cubed. All right, so we get y prime is equal to, so what does it say? See how we have this function here inside the parentheses? So we bring the 3 down and subtract 1 from the exponent. Okay, that's the first part of it. Now it's times the derivative of what's inside the parentheses. So what's the derivative of 2 minus 3x? Well, that's negative 3. So we get y prime is negative 9 times 2 minus 3x squared. And there's your answer. All right. Let's look at another one. Now, let me say this about these problems. See how this is in parentheses to the cubed? Believe it or not, I've had students on the test that write this out like this, multiply it all out, and then take the derivative. Don't do that, okay? I mean, I've even had this exponent a 7, and I've had students try to multiply it out and then take the derivative. So don't do that. Just use the chain rule. It's easy. Just a couple of steps. All right, let's look at this one. All right, so same thing. So we get f prime of x is equal to, so the 4 comes down, 1 minus 3x squared cubed. So the 4 comes down, subtract 1 from the exponent, and then it's what? Times the derivative of what's inside the parentheses. So the derivative of 1 is 0, the derivative of negative 3x squared is negative 6x. And so I get f prime of x is equal to negative 24x times 1 minus 3x squared cubed. And there's your answer. All right. Let's look at another one. All right, so this one. All right, we know how to do this. This is what? This is a quotient rule, right? See, we got a fraction. We got to do the quotient rule. This was the last video. All right. So remember, the quotient rule is the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, and then all of that over the denominator squared. All right, so we've got y prime. All right, so it's the derivative of the numerator. So take the derivative of the numerator. What do we have to do to take the derivative of the numerator? We got to use the chain rule. 3 comes down, subtract 1 from the exponent, times the derivative of what's inside the parentheses. So what was the derivative that's inside the parentheses? 3. That's where that 3 comes from. And then it's times the denominator. So remember, this is the derivative of the numerator. Whoop. This is the derivative of the numerator times, and then this is the denominator. All right? And then it's what? It's minus the derivative of the denominator. What's the derivative of the denominator? Negative 1. Derivative of 1 minus x is negative 1 times the numerator. And then this is all over the denominator squared. All right, now, don't leave your answer like this. Simplify it. Okay, so let's clean this up some. So this is going to be 9 times 1 minus x times 3x minus 1 squared plus 3x minus 1 cubed over 1 minus x squared. All right, yes, I wrote the 1 minus x first. Makes no difference, okay? We still got some stuff we're going to simplify. All right. So what is this? This is going to be y prime equals, all right, so watch this, 3x minus 1 squared times 9 times 1 minus x plus 3x minus 1 over 1 minus x squared. All right, so what in the world did I do here? Okay, well, let's look at this. Do you see how I have a common factor of 3x minus 1 squared? I factored that out. And so what happens when I factor out a 3x minus 1 squared? Well, in this term, that factor's gone. And so we're left with 9 times 1 minus x. And then when I factor it out of this term, I'm left with it to the first power. And so that's where that 3x minus 1 comes from. Okay, so I just factored out the common factor, greatest common factor. And so now I get y prime equals 3x minus 1 squared times 9 minus 9x plus 3x minus 1 over 1 minus x squared. I just distributed the 9. Now I'm going to combine like terms, so I get y prime is 3x minus 1 squared times, what is that, negative 6x plus 8 over 1 minus x squared. And there's your answer. All right, so it's not that bad. It's a little more to it when you're simplifying. And if you're in my class, yes, you have to simplify it to that, okay? And I'm sure most of you that's watching this that are not in my class, your teacher's probably going to want you to simplify it to this also. All right, so let's look at this. Y equals the square root of x squared plus 1. So in the 3 previous examples, what have we been talking about? We have something in parentheses, right? Raised to a power. So the exponent comes down, subtract 1 from the exponent, then it's times the derivative of what's inside the parentheses. Now, in this problem, y equals the square root of x squared plus 1, do we have something in parentheses raised to a power? And the answer is, we actually do. Can't we rewrite square root as a 1/2 power? So you can see here we have something in parentheses raised to an exponent. And so that's going to be y prime. The exponent comes down. Subtract 1 from the exponent times the derivative of what's inside the parentheses. So the derivative of x squared plus 1 is just 2x. And so now we get y prime is equal to 2x over 2 times x squared plus 1 to the positive 1/2. Okay, so look, you can look at this as all being over 1. We've got a negative exponent, so we move it down to the denominator to change it to a positive exponent. And you can see now the 2's cancel. I'm left with y prime is x over the square root of x squared plus 1. All right. Now, let's just stay on this problem for just a second. Okay. Now, that's fine and everything. Changing it to be in parentheses raised to the 1/2 power. Okay. Now, there is a shortcut for finding the derivative of a square root. And we're going to work this problem again using the shortcut. Now keep in mind, this only works on square roots. It does not work on cube roots, fourth roots, fifth roots. It only works on square roots. So let's write the problem down again. All right. So we got y prime is equal to, draw your fraction bar. In the denominator, put a 2. It's always going to be a 2. And then next to it, whatever your problem, whatever that is, whatever your square root is, every time. Okay, that goes in the denominator. Now, look underneath the square root. What's the derivative of that? 2x. And so the 2's cancel, and I'm left with x over the square root of x squared plus 1. And there's your answer. So, how do you want to work it? Me personally, I like the shortcut better. Now, if you have a cube root, yeah, you're going to have to change it to this and then take the derivative. Okay? But if you have a square root, just use the shortcut. Okay? If you're in my class, you can use the shortcut. All right? But, you know, you may want to check with your teacher first. All right. So let's look at the next one. We've got y equals 6 times the cube root of x squared. All right, so to find the derivative here, the first thing we're going to need to do is rewrite this as x to the 2/3. All right, rewrite it as x to the 2/3. Now take the derivative. This is just a power rule now. Like that first section we did when we first learned how to take derivatives. X to the n. So I've got y prime is 6 times 2/3, so that's 4. So if you got 6 times 2/3, the 3 and the 6 cancel, you're left with 4. X to the negative 1/3. So I get y prime is equal to, that's an equal sign there, is equal to 4 over x to the 1/3. And there's your answer. All right. I didn't leave myself a lot of room on these problems, did I? All right. So what about this one? All right. So the first thing that might pop into your head on this one is, well, I've got quotient rule. And yes, it is a quotient rule. You've got a fraction there. And if you do the quotient rule, you're going to get the correct answer. But I think it's a little easier to do it like this. So look at this. Notice how we have a number right here. You see that 1? There's no variable. There's no variable in the numerator. It's just a number. So if you just have a number in the numerator, just bring this up, okay? And I tell you what, let's do this. Let's change that 1. Let's just change it to a 2. Okay, let's change the problem up. So y equals 2 times 1 minus 4x to the negative 5. Okay, so we just brought that up. Now it's just a chain rule. We don't have to do the quotient rule. A lot of times if you can avoid the quotient rule, do it. Okay, avoid the quotient rule. All right. So now we get y prime that's going to be what? Negative 10 times 1 minus 4x, subtract 1 from the exponent, so that's negative 6, times the derivative of what's inside the parentheses. So that's times negative 4. And so now I get y prime equals 40 over, I'm going to bring this to the denominator to make that exponent positive, 1 minus 4x to the 6th. And there's your answer. All right. I just think in this case, I think it's easier to just do the chain rule rather than do the quotient rule. All right. Next one. So how about this? Well, we got product rule. So that's y prime. So what does the product rule say? The derivative of the first times the second plus the derivative of the second times the first. Here's your first function, x squared. Here's your second function, 1 minus 3x to the 5th. So the derivative of the first, 2x, times the second, okay, plus the derivative of the second function. So now we've got to take the derivative of 1 minus 3x to the 5th. We've got to do chain rule there. So that's 5 times 1 minus 3x to the 4th. The 5 comes down, subtract 1 from the exponent, times the derivative of what's inside the parentheses. So what's the derivative of 1 minus 3x? That's negative 3. And then times the first function. All right, so we did product rule there. So now I get y prime is 2x times 1 minus 3x to the 5th minus, what is that, 15x squared times 1 minus 3x to the 4th. Whoop. All right. And you guessed it. We're going to factor out the greatest common factor. So we've got y prime is equal to x times 1 minus 3x to the 4th. See that? I have a common factor of 1 minus 3x to the 4th, and I have a common factor of x that I factored out. And so that is going to leave me with 2 times 1 minus 3x. That's what I'm left with this one. See, I factor out a 4th power, so I'm left with the 1st power there. And then minus, so here we're factoring out a 1 minus 3x to the 4th, so this one's gone, and this one changes to the 1st power. So that's minus 15x. And so I've got y prime is x times 1 minus 3x to the 4th times 2 minus 6x minus 15x. And so y prime is x times 1 minus 3x to the 4th times, was that negative 21x plus 2. And there's your answer, provided I did not make a stupid mistake. Okay. All right, so hopefully that makes sense. And look, yeah, go ahead and factor that common factor out. We did it earlier when we did the quotient rule, and now we're doing it again when we do the product rule. This just looks better than leaving it like this. Okay. Okay, so evaluate the derivative. Y equals x over the square root of 1 minus 4x. Okay, so for this one, we need to use the quotient rule. All right, so I've got y prime is the derivative of the first times the second. derivative of the first times the second. I'm sorry, I don't know what I'm saying. The derivative of the numerator times the denominator. Sorry about that. All right, minus the derivative of the denominator. Now look, remember what I showed you. 2 square root 1 minus 4x. That always goes on bottom. I'm taking the derivative of the denominator first. And then what goes in the numerator? The derivative of what's underneath the square root. And then that's times x. And this is all over the square root of 1 minus 4x squared. All right. So let's just kind of clean it up a little bit before we start simplifying it. And so this is going to be the square root of 1 minus 4x plus 2x over the square root of 1 minus 4x over 1 minus 4x. Because when you square a square root, you get what's underneath the square root. Okay? Now technically, I mean, all we're doing here, our main goal here, is to evaluate this thing at -2. That's what we're trying to do. So we could take the -2 and plug it in and evaluate it. Okay? But guess what? We're not going to do that. We're going to simplify it some more. Some good practice for you. All right. So how in the world do I simplify that thing? Well, we can look at all of this as each of those being over 1. We got a complex fraction, right? So I can multiply each term by the common denominator of 1, 1, and square root of 1 minus 4x. So let's do that. So times square root of 1 minus 4x times square root of 1 minus 4x and times square root of 1 minus 4x. Multiply each term by the common denominator. And so this is going to give me 1 minus 4x. Multiply 2 square roots. They got the same thing underneath the square root, so you get what's underneath the square root. And then look at this. See how nice that is? That just cancels out. And we're left with plus 2x over. And then, now look, think of this part right here. This is what? This is 1 minus 4x times 1 minus 4x to the 1/2. What happens when you have like bases? That's 1 minus 4x. That's the exponent of 1. And that's what? 1 plus 1/2, which is 1 minus 4x to the 3/2. So that's over 1 minus 4x to the 3/2. All right. Remember, when you're multiplying, you have like bases, you add the exponents. And so now I have y prime is equal to 1 minus 2x over 1 minus 4x to the 3/2. And then what do they want us to do? They want us to find y prime of -2. Of -2. So that's going to be 1 minus 2 times -2 over 1 minus 4x. I'm sorry. 1 minus 4 times -2 to the 3/2. And so that's going to be, what is that, 5 over 9 to the 3/2. All right. You could leave it like that, but don't. What do we get? Look at this, 9 to the 3/2. You remember your algebra? That's the square root of 9 cubed, which is 3 cubed, which is 27. So that's 5 over 27. And there's your answer. All right. So look at this. What looked like something, this right here, that looked like, oh gosh, we got to simplify that thing. Well, look, just by multiplying everything by the common denominator, look at the next step here. That's easy there. You see that? All right. Okay, so let's look at this. It says the electric resistance R of a wire varies inversely as the square of its radius R. For a given wire, big R is equal to 4.66 ohms. For little r, the radius, equals 0.15 millimeters. Find the derivative of R, big R, with respect to little r for this wire. So all they're wanting us to do here is find the derivative of big R with respect to little r. All right? But wait a minute. They don't give us a function. They don't give us a function to take the derivative of. But let's see what it says here. It says big R varies. See, big R varies inversely as the square of its radius, little r. So what does that mean? That means big R is equal to k over r squared, right? Remember that from algebra? Remember, varies directly, varies inversely, varies jointly. If it varied directly as the square of its radius, that would be k times r squared. Inversely is k over r squared. All right, so what do we need to do? What do we need to do to take this derivative? Well, we know how to take the derivative, but there's something we need to do first. We need to know what k is. K is a constant, right? Well, it tells me for a given wire, big R is 4.66, when little r is 0.15. Okay, so that would mean 4.66 is equal to k over 0.15 squared, right? If I take this and plug it in for big R and this and plug it in for little r, well, look at this. Now I have an equation I can solve. You see that? I have an equation I can solve. So this tells me that k is equal to 4.66 times 0.15 squared. So k is equal to let's see, what is that? 0.105. There's k. So now I can write r is equal to 0.105 over r squared. All right? So now we need to do what? We need to take the derivative. Now, what can I do here? Yes, I could do the quotient rule, but why? Why would we do the quotient rule? Let's rewrite r is 0.105 r to the negative 2. Just bring this r squared up into the numerator. It changes the sign, right? Changes the sign of the exponent. And now I just got a simple power rule. And so I get r is equal to negative. And what in the world is that? That is that negative? Let me get my calculator. I could probably do it in my head, but I don't want to write something down wrong. It'll be all in the comments if I do. Negative 0.21 times r to the what? Well, I subtract 1 from the exponent, so that's negative 3. And so that's going to give me r is equal to negative 0.21 over r cubed. And I moved the r to the negative 3, moved that back down to the denominator to make the exponent positive. All right? All right, so let's look at this one. Is this the last one? No, we got one more after that. Okay, but this is fun. Keep watching. All All right, so water is slowly rising in a horizontal drainage pipe. The width W of the water as a function of the depth H is W is equal to the square root of 2RH minus H squared, where R is the radius of the pipe. Find the derivative of W with respect to H. For H equals 2.25 inches, and I put two ands in there, didn't I? And R equals 6 inches. Okay, so what do we have to do? So we got W equals the square root of 2RH minus H squared. All right, so I need to take the derivative of this thing with respect to H. With respect to H. H is my variable. R, you see the R right here? That R, you treat that like a number. So I've got the derivative of W with respect to H. Oh, this is nice, isn't it? Remember the shortcut I showed you for finding the derivative of a square root? It's 2 times whatever that square root is, and then what goes in the numerator? The derivative of what's underneath the square root. So the derivative of 2RH, 2R is a number. So look, 2R is a number. You got a number times H. What's the derivative of 5H? 5. What's the derivative of negative 6H? Negative 6. What's the derivative of 2RH? 2R minus 2H. The derivative of H squared is 2H. All right, and then look at this. You see we can cancel out all those 2's there, and so we get dW dH is equal to R minus H over the square root of 2RH minus H squared. And then what do they want us to do? They want us to evaluate this when H is equal to 2.25 and R is 6. All right, so dW dH evaluated at those, that's going to be 6 minus 2.25 over the square root of 2 times R, which is 6, times, oh, wait a minute. Yeah, that's right. 2.2, I thought I wrote something down wrong, but I didn't. Minus 2.25 squared. Okay. And so we get dW dH is equal to, and so we get an answer of 0.801, and that's provided I think I put it in the calculator right. I didn't double check it. I just put it in there once, but if that's the case, then I hit a button wrong in my calculator, okay? But I don't think I did. So that's what you should get when you simplify that or punch it in your calculator. All right, so let's look at this last example here. So find any values of x for which the derivative of this thing is 0. So we've got quotient rule here, don't we? And look, yes, if you wanted to, you could actually change this to x squared plus 1 to the 1/2 and use the chain rule. But remember, we talked about the shortcut for finding the derivative of a square root. And that's what I'm going to use. So I get y prime is equal to the derivative of the numerator times the denominator minus the derivative of the denominator. So what goes in the denominator? 2 times that square root. What goes in the numerator? The derivative of what's underneath the square root, and then times the numerator. And this is all over the denominator squared. All right. And look, this is, let's go ahead and let's multiply this 2x and x squared and cancel those 2's. So I get y prime is 2x square root of x squared plus 1 minus, so the 2's cancel. That's going to leave me with x cubed in the numerator, and that's square root x squared plus 1. And that's all over the square root of x squared plus 1 squared. All right. So look, all we're going to do here is we're going to simplify just like we did before. All right. Look at this as being over 1. This is being over 1. And I'm going to multiply everything by the common denominator of 1, 1, and square root of x squared plus 1. So everything's getting multiplied by square root of x squared plus 1. All right. And so I get y prime. That is going to be 2x times x squared plus 1. So that's 2x square root times square root. That's just going to leave me with x squared plus 1 minus x cubed. And that is going to be over x squared plus 1 times the square root of x squared plus 1. All right. And so this gives me y prime is, what is that, 2x cubed plus 2x minus x cubed over x squared plus 1 times the square root of x squared plus 1. And so this is y prime is equal to, that is what, x cubed plus 2x over x squared plus 1 times square root of x squared plus 1. All right, so I know what you're probably thinking here, because I've been telling you, telling you to simplify things. And on the last problem, we did multiply those out. Remember, we got a 3/2 power. But look, on this one, I mean, if you want to, you can write that as x squared plus 1, all that raised to the 3/2. But look what the problem's asking us to do. Find any values of x for which the derivative of this is 0. So in this problem, we want to know, when is y prime 0? Well, remember, y prime is 0 when the numerator is 0, right? That's when a fraction 0 is when the numerator is 0. So we don't really care about the denominator. So y prime equals 0 means that x cubed plus 2x equals 0. And then we just have to solve that. So we'll factor out x, and so I'm left with x squared plus 2 equals 0. So I get x equals 0, or x squared plus 2 equals 0. We'll talk about this one over here, but I get x equals 0. But look at this one. That one's never going to be 0, is it? Look, if you do x squared equals -2, then you've got x equals what? Plus or minus I square root of 2. That's an imaginary number. This side over here, that'll never be 0. Okay? So the only time that the derivative is going to be 0 is when x is 0. All right, so guess what? I know you're sad now. That's the end of the video. But yeah, that's it. That's chain rule. We did chain rule, we did some product rule, quotient rule, but when we did the product and quotient rule, we had to do the chain rule, in that. So that's quite a few examples. I hope this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.